In this activity, we will be learning how we can find the formula for volume of a right circular cylinder. So the objective of the activity is to find the formula or to derive the formula for the volume of a cylinder, and that too experimentally. Let's see the concept involved in this activity. You all know that a cylinder has two dimensions. So if I draw a rough cylinder here, the upper surface is circular, then we have the curved surface, and at the base also we have a circular plane. So there is the radius of the two bases, which is common, that means the same radius, and the vertical distance between the centers of the two circles is the height. So we have two dimensions, r, the radius of the circle or the radius of the cylinder, h is the height of the cylinder. So when we have to find the volume of the cylinder or to derive the formula for volume of the cylinder, we have to consider this as a 3D object and then cut it in some parts, which we will be doing in the activity, and convert this cylinder in the form of a cuboid. Then we will see that the length, breadth and the height of the cuboid, if you multiply the three, you will get the volume of the cuboid. And since we converted the cylinder in the shape of cuboid, the volumes will be equal. The length of the cuboid will become equal to pi r, as we will see in the activity. The breadth will be equal to the radius and the height remains same as the height of the cylinder. All these three will be verified in the activity, and when we obtain the volume of the cuboid, you will obtain the volume of the cylinder also. The material required for performing this activity is plastic clay, which is readily available in the market, a cutter to cut the plastic clay in a particular shape, and then little bit of thermocol so that you can place those plastic clay pieces and derive that shape of cuboid. So let's now see how this activity can be done experimentally. In this activity, we require plastic clay. So you can see three figures are drawn here. One shows a cylinder of radius r and height h. And this is what this plastic clay is converted into, a cylindrical shape. After that, we make vertical sections on this plastic clay and make 8 parts of this cylinder. Just like this, if I show you the top portion, it shows 8 different parts. So I've already cut it into 8 parts so that it's easier to perform the activity, but you will have to put like the cutter in between this and then cut it like this into 8 equal parts. After that, when you obtain 8 equal parts, you will separate the cylinder into different parts like this. So you will obtain 8 sections, and all these 8 sections are now to be arranged in the form of a cuboid, just like shown in this figure. When you convert the figure into the shape of a cuboid like this, you can see 8 sections, 1, 2, 3, 4, 5, 6, 7, 8. 4 of the sections are above and 4 sections are below. So it resembles more like a cuboid. So what happens with this is the base, that means this part, is equal to the semi-perimeter or semi-circumference of this circle, because 4 parts are below and 4 parts are above. So these 4 parts form half of the circumference, that is 2 pi r by 2, which is pi r. And the width of this cuboid will obviously be equal to the radius, because this is inclined like this, and the same thing was present here in the figure. So this is r, which is equal to the
breadth, and finally the height of the cylinder and the height of the cuboid will obviously be the same. So the length becomes pi r, the breadth becomes r, and the height remains h. So volume of this cuboid will be LBH, and if you put all the formulas, all the derived values here, L is pi r, B is r, and h remains h, you will obtain the formula for volume of the cylinder, that is pi r square h. And that completes our activity on finding the volume of a cylinder.